All right, so we are starting 12.1, which is parallel lines and transversals. And so before we start, I want you to write down that learning goal that says that I can find angle measures when a transversal intersects parallel lines. And so that's our goal for the end of class. That's something that we will be able to do. There's a couple things that we don't actually know in the learning goal, and so transversal being one of them. So we're going to look down here at the vocab section, and we're going to write down that vocabulary definition for transversal. A transversal is a line that intersects two or more lines. So for example, if I go up here to this drawing, line A and B, if I draw a line down them, then that is a transversal because it intersects both line A and B, meaning that it cuts through the two lines. The next thing would be parallel lines. We need to understand the definition of that in order to be able to prove angle measurements. So I didn't actually add this on your note sheet, my bad. I want you to write it on yours somewhere. So parallel lines are two lines that never cross or never meet, and they're equal distance from each other at all times. So if we go up back to this example, these two lines A and B are not parallel because the distance over here between A and B is different from the distance over here between A and B. And so that means at some point, if these lines continued forever, they would actually cross each other. And so we want two lines that would never meet to be parallel. We're going to skip the exploration and we're going to go straight to the examples today. And so we're going to start by finding angle measurements. So we're going to use this figure over here in order to do that. This figure has a bunch of important things on it that we need to know before just jumping into part A and part B. So first we need to know that the A and B over here, this A and B, these are the names of the two vertical lines. So we have a vertical line named A and a vertical line named B. Over here, this T, this is the name of the transversal, so the line that is cutting through both of them. The next important part would be these two little arrows. These arrows are really, really important. They mean that the two lines are parallel. So that means that they are equal distance and that they will never cross each other. And that's really, really important because if those symbols weren't on there, we would not be able to find the angle measurements. So let's jump into part A. It says that angle 1, which is right here, and it's angle 1, not the measure of the angle. So this is not 1 degree. We are looking at this angle to try to determine the measurement of it. So when they say angle 1, it's just saying where on the figure we are looking. So angle 1 and the 110 degree angle are corresponding angles formed by a transversal intersecting parallel lines. The angles are congruent. So congruent means that the two angles are going to be equal. That's what congruent means. And so that means that angle 1 is equal to 110 degrees. So we're going to go up here to corresponding angles, which I'm going to put my definition over here because it's a little bit, well, not right there. We're going to go right here. It's a little long for it to fit there in my box. So a corresponding angle are angles that are in the same position on the figure and a transversal cuts the two parallel lines, and that's what makes them equal. So they have to be parallel in order for these corresponding angles to be equal. So if you look, angle 1 and 110 degrees, those are both in the bottom left corner of our two lines and our transversal. So since they're both in the bottom left corner, then we know that they are corresponding. And since the two lines are parallel, we know they are equal. So angle 1 equals 110 degrees. Part B is saying that angle 1 and 2 are supplementary. So these two angles here make up that line. And so a little while ago with a couple of topics, we wrote out the word supplementary. and we turned that into 180 to remember that a supplementary or two supplementary angles add up to be 180 degrees. So now we're going to find the measure of angle 2. The measure of angle 2 is 180 minus what we know, and we know that angle 1 is equal to 110 degrees. So we have 180 minus 110, which equals 70 degrees. So angle 2 equals 70 degrees. So just by knowing one angle measurement, we're able to find out other measures on that figure. So now we're going to try another example using the figure to the right. So it says that this angle is 63 degrees. And so we want to figure out what angle 1 is. So 63 is in the top right corner of line L. So we're going to look at line M. The top left or the top right corner is our corresponding angle, which means that angle 1 actually just equals 63 degrees. So now we're going to use our supplementary angles, angle 1 and angle 2, to figure out what angle 2 is. So we have 180 degrees minus 63, and that equals angle 2. And so that's 117 degrees. So angle 2 equals 117 degrees. All right, corresponding angles. So we're going to use corresponding angles to figure out all 7 of those angle measurements. So I'm just going to write down angle 1, angle 2, angle 3, angle 4, angle 5, angle 6, and angle 7, because we're going to figure out what all of those actually equal. So they gave us the angle of 75 degrees, and so I'm going to use corresponding angles to figure out which ones also are equal to 75 degrees. So my corresponding angle with the 75 is the 6, and so that means that angle 6 equals 60, not 65, that was the last, 75 degrees. So those two are equal. Now I'm going to use supplementary angles to figure out angle 3. So I'm going to do 180 minus 75 to get angle 3. That gets us 105, which means that angle 3 is 105 degrees. All right, so now I'm going to look at corresponding angles again, and the corresponding angle for 3, since it's in the bottom right corner, the bottom right corner of part B, or of line B, is 7. And so that means that 7 is also 105 degrees. Using supplementary angles, I'm going to find angle 4, because angle 4 plus angle 7 gives me that straight line, which is 180. So 180 minus my 105, that equals 75. So that means that angle 4 equals 75 degrees, which actually makes sense because we know that vertical angles are two angles that are across from each other, and vertical angles are equal. And so if vertical angles are equal, then that means that if that's 75, then 1 would also be 75 because it's vertical from our given angle. And then I'm going to use another color. 2 and 3 are vertical, so that means that 2 is the same as number 3 or angle 3, which is 105. And 5 and 7 are vertical, so that is also going to be 105. Which makes sense because 2 and 5 are corresponding angles, so they should be equal. So given one angle measurement and knowing that these two lines here have those arrows on them, we know that they're parallel. So by using that one given angle, we were able to figure out all 7 of the other angles on that figure. So now I want you to try this one. Again, we're going to have angle 1, 2, 3, 4, 5, 6, and angle 7. So they gave us an angle that is 59 degrees, and we are going to figure out the rest of them. So corresponding angles, I'm going to highlight in blue. So my corresponding angle is angle 5. And so since angle 5 is corresponding, they're the same, which means that angle 5 is 59 degrees as well. I'm going to use supplementary angles now to figure out angle 6. So I'm going to do 180 minus that 59 degree angle that I know of, and I get 121. So that means that angle 6 equals 121 degrees. And using corresponding angles, my yellow angles here, 6 and 3 are corresponding, which means that angle 3 is also 121 degrees. I'm now going to use my vertical angles to help me solve for the rest of them, because vertical angles mean that they are equal as long as they are across from each other. My stomach is growling, so please enjoy that. So my vertical angle for 3 is number 1, and for 6 is number 4. And so those are equal. So since 3 was 121, that means that angle 1 is 121. And since 6 is 121, angle 4 is also 121. Now I can use vertical angles again for 5 and 2, not 5, 7. 5 and 7 are corresponding, so those are equal. And 7 corresponds with 2, which means that that is also a 59 degree angle. So again, by just knowing one angle measurement, we're able to find the rest of them on that figure. All right, so now identifying angle relationships. So the photo wants us to describe the relationship between each pair of angles. So angle 3 and 6. So let's find 3 and 6 on our image. So 3 and 6. So those aren't corresponding, and they also are not vertical angles. And so how do we solve this? Well, we need to know that these are on the outside of our figure. So the inside of our figure would be what's on the inside of those two parallel lines, and the outside would be the numbers and the two angles on the outside of those parallel lines. So those are called exterior angles. And since they're exterior angles, we could actually move these to go here since they're parallel, which means that 5 and 7 match up with 1 and 3, and so they're equal. So with that being said, 3 corresponds with 7, and 7 is vertical angle from 6, so they're actually equal or congruent. All right, so now let's look at angle 2 and angle 7. So angle 2 and angle 7. These are interior angles. And since they're interior angles, and the two lines are parallel, 7 corresponds with 3, just like we said before, and that's vertical angle from 2. It means it's across from 2, so they're equal. And so these two are vertical angles and they are congruent. So a little rule, if you have interior angles, the diagonals from those are always equal. So 2 is equal to 7, 5 is equal to 4, and then on the outside, on the exterior angles, I'll put that in green, 6 and I think that was 3 are equal, and then 1 and 8 are equal. So that's the rule for exterior angles and interior angles. So now knowing those rules, we can figure out angle 3, 5, and 6. So I want you to do this part on your own.